So in this lecture, we're going to talk about one of the things that you can do to, in a sense, complete a relation, right? This one, for example, if you take a look at this, you can see pretty quickly that this relation is not transitive, right? We have 1 is related to 2, right? Because 2 is equal to 1 plus 1. And we have 2 is related to 3 because 3 is equal to 2 plus 1, but 1 is definitely not related to 3, right? 1 is not equal, 3 is not equal to 1 plus 1. Okay, so in a sense, this relation is incomplete. The question here is, what can we do about it? What would we have to do to fix this in the sense of making it into a relation that is transitive? Well, essentially the answer to that is going to be you got to add some ordered pairs, or you have to add ordered pairs that fill in those missing relations. So here's how we're going to do that. All right, we're going to start with the original set and the original relation. And we're going to build this thing called the transitive closure of the original relation. And the way we're going to symbolize that is with an R, again, because it's kind of making the connection back to the original relation. And we're going to put that superscript T. All right, so what properties does this thing have to have? Well, first, it has to be transitive. That is kind of the point, right? We want this to be a transitive relation. The original relation is a subset of the new one. Okay, so this new relation has everything that the original one had plus some. And finally, if S is any other transitive relation that contains R, then our new one is a subset of that one. So this last one, what this last property says is our new transitive relation is, in the sense of subsets, it is the smallest transitive relation that contains the original one. All right, so let's see what this is going to look like. Back to our original relation here. All right, so what we need to do here is we need to start by thinking about what the original relation is in terms of ordered pairs. So we have the ones we saw previously. We saw the 1 is related to 2, right? 1 plus 1 is 2. 2 is related to 3. And I think those are the only those are the only 2 pairs in our relation. So the only 2 that we have here are 1, 2, and 2, 3. So you're thinking here, right? I want to build this RT, this transitive closure. So to do that, I have to think to myself, okay, well, what are the transitive relationships that I could build from this? Well, we saw on the last slide, right? If 1 is related to 2 and 2 is related to 3, then if this is going to be transitive, it must also include 1R3. So I have to add that one in. Okay, so and I don't have to add anything else. Right? It's nice since it was very small, right? And there were only 2. So these 3 ordered pairs together would be RT. This would be my transitive closure, right? And to take a step back, right? I made a kind of bold claim there. Think about the definitions, right, of a transitive closure. First, yes, this is transitive, right? Second, it is the original relation is clearly a subset of this, right? These were the only 2 things in the original one, and they are in my new one. And usually the trickiest part of this is proving that this is the minimal one, but I only added 1 element, right? It's hard to make something smaller than this because I only added one thing, right? So yeah, this is also the smallest such transitive subset, transitive relation. Okay, so where are we going from here? Well, this kind of ends our discussion of the basic properties of these relations. So in the next series of lectures, we're going to start to look at some of the implications of this. Right? What sorts of things can we do with these relations?